All right, you guys, we're on the very last one of Unit 5, which is Day 5. And after adding and subtracting fractions and then multiplying fractions, today we get to divide fractions. So before we do division of fractions with variables and factors and all of that, I just need to remind you that whenever you divide with fractions, actually, you'll never do that. Instead, you multiply by the reciprocal. And I think everybody probably remembers that a reciprocal is just simply a flip of the fraction. A quick example with some of those old-fashioned numbers is if you have something like, let's say 12 fifths, and you're dividing that, so big fraction bar, let's say we're going to take 12 fifths and divide by 2/3. This division bar that's in the middle, and I'm making it very big and obnoxious looking, that one actually gets rewritten as the numerator, 12 fifths. So think of parentheses around that. And instead of dividing by 2/3, this denominator, you're going to multiply by the reciprocal of the denominator. So this is the one that gets reciprocaled, and it turns into 3/2. And then you can, of course, find your common factors, and I'm going to rewrite 12 as 6 times 2, and then the other numerator is a multiplier of 3, and in the denominator we've got 5 times 2, because now you can cancel the 2 and get your answer of 18 fifths. So let's see if we can extend that idea to all of this stuff with rational expressions, meaning variables, x's and y's. So we'll copy this one down, and the first thing, of course, to draw your attention to is that whenever you have a division, you're going to rewrite the problem and multiply by the reciprocal. Now, looking ahead, you can start to see that there's going to be some things that are going to cancel. So I'm going to rewrite this first x cubed as x squared times x. You'll see why in a sec. And then in the denominator, we'll have 9. That's being multiplied by x squared and then multiplied by y. Sometimes it helps people if you put all those dots in place. And then instead of division, we're going to turn it into a multiplication job and flip the second fraction. So now 9y to the 5 goes on the top. So that's 9 times y to the 5th. And then in the denominator, we're going to have just our 16, but I'm going to choose to rewrite 16 as 4 times 4. Just looking ahead, you can start to see that everything that you have on the top is going to get multiplied. So I'm going to do a quick job here. Check out what I've got. I'm going to erase that dot in the middle. I'm going to extend my fraction bar and re-put the dot here and here in this problem. So now whatever's on the top and whatever's on the bottom, those are cancelable factors. In other words, one of the 4's on top can cancel with one of the 4's on the bottom. One of the 9's can cancel. You got an x squared that can cancel with another x squared. And I chose to not rewrite y to the 5th because now you can think of it as canceling this y on the bottom with one of the y's on the top, which will knock your y to the 5th down to y to the 4th. So that's like a normal step that people take often when you're working with these fractions. So overall, for our final answer, on the top, we got an x and we got a y to the 4th, so xy to the 4. And in the denominator, the only thing that didn't cancel is a 4. So there's your final fraction answer. And then you give me the restrictions like usual. Now, this is the part that you got to really be careful of, because let's think about it here. And I'm going to do some highlighting just because I can and it's easier to see. Of course, this 9x squared y was in the original denominator. We were dividing it by 16 over 9y to the 5, so 9y to the 5 was in the original denominator. But then in the process of timesing by the reciprocal, the 16 got put in the denominator. So really, when you guys are listing the restrictions, you're going to have to look in all 3 of those spots, meaning all 3 of those spots for any potential restrictions. It looks like the only variables that we have are x's and y's. So you're going to say x cannot take on the value of 0 as well as y cannot equal a 0 for those restrictions. So the tricky part on the division ones, on the dividing problems, is that you've got a lot of places that could give you potential restrictions. So let's go ahead and try this one out. And this is our last example. This is pretty short stuff. I'm not going to demean your intelligence by forcing you to do way extras. But let's take a look at this very first problem, and I see a GCF. Hopefully you guys see it all. You're going to have to start, remember, training your brains to look for greatest common factors. And in this case, the GCF is x cubed. What's left in parentheses then is going to be an x squared minus 4. That denominator does not have a GCF, but it's got x squared. So that's when you factor it into your two binomial terms. Looks like we'll be able to have an x and an x, and then numbers that multiply to make -2 that add to -1 will be a -2 plus 1. Then, instead of dividing, we're going to multiply by, and let's do a reciprocal. So the reciprocal says that x squared minus 1 is on the bottom, so now you're going to have x squared minus 1 on the top, but let's start factoring that. It's a difference of squares, an x and an x, a plus and a minus, and then ones. The denominator of that reciprocal is now this big thing. I'm circling it in pink so everybody can see what I'm talking about. And that big thing has a very big common denominator, or sorry, common factor, a GCF of 3x cubed. So when you factor out that 3x cubed, what's left in parentheses when you divide that by each one of those terms is 2x squared minus 3x plus 1. And then we're back to our normal multiplication problem, but there's still a little bit more factoring to go. We've got some additional x squareds. So I'm going to do another equals, and then one giant fraction bar because we don't have to times by any reciprocals. So I'm going to just take all of the tops. First piece is x cubed times. The next piece is x squared minus 4. Since there's a squared, we're going to do some more factoring. An x and an x, a plus and a minus, and then the square root of 4 is 2. Then there's our multiplication, because that was our original break in the two fractions, but we're just going to keep plowing through. The next two factors are x plus 1, x minus 1, so those are already factored down as far as they can go, so copy them. In the denominator, the very first denominator was x minus 2, and then x plus 1. Then there was the break in the fraction, which we turned into times, so I'm still just showing the multiplication. Then we had the 3x to the third, so that just stays 3x to the third. And then we have our 2x squared minus 3x plus 1. This is those uncomfortable ones that everybody's like, ugh, it's one of these. Yep. So the only numbers, and I'm just going to show you the quick, fast and easy way to factor this. Let's look where I just had that green arrow. The only numbers that multiply together to make 2 are 2 and 1. So in each of these binomial factors, you're going to have a 2x and a 1x. And then in the very good news category, the only numbers that multiply together, look at the next green arrow, to make 1 are 1 times 1. So the only choices are putting a 1 and a 1 at the end of the parentheses. But since this middle term right here, again looking in green, since that middle term is a -3, that means that each one of these symbols is a minus and a minus. Don't forget to loop check. My inner loop gives me a -1x, and my outer loop gives me a -2x for a total of -3x, and that works, so we're good to go. I'm going to erase my loop check because that's in the way. And now we do the fun part of them all. Cancel, cancel, cancel. In terms of factors, I got an x minus 2 that can cancel on the bottom with an x minus 2 on the top. And an x plus 1 on the bottom with an x plus 1 on the top. And an x minus 1 on the top and on the bottom. And here's the other piece. Right here, we've got 3x cubed, which means 3 times x cubed. So if you want to think of those as two separate factors, the 3 factor and the x cubed, that's fantastic because you can take the x cubed and cancel with the x cubed factor on top. So your grand total final answer, the only thing that didn't cancel from the top was x plus 2. And your grand total final answer for the bottom, you got a 3, and then there's a 2x minus 1. And then it's done. Now, listing the restrictions is super annoying. Get ready, get set. Here we go. The easiest restriction of them all is to just give the restriction from the remaining denominator, which is 1/2. But then you got to go back and you got to look at all of the denominators. So here's the deal. Remember at the very beginning, we had a denominator, and then we flipped it. So we have those three pieces. In other words, the only thing that never has to be concerned with is this piece, which is this piece, which was this piece. Everything else is fair game for restrictions. So I've circled that in yellow highlighter. Everything else is a potential restriction. So it looks like everything else after that, I've got x plus 1, x minus 1. So x can't equal plus or minus 1 either. In the denominator, I see I got an x minus 2, so it can't be a positive 2. I almost messed that up. Whew. I got the 1, so that's all good. Oh, we canceled this factor of the x cubed, so x can't take on the value of 0. And I believe then we have everything listed. So you've got to be super, super careful as you do these homework problems for the division restrictions, because almost everything can give you a restriction when you multiply by the reciprocal. And that's it, folks. Let's go ahead and get rolling, and here we go.